In this video, we'll be looking at some examples of quadrant properties with regards to calculating exact values of circular functions, so such as sine and 90 degrees, which we've already calculated before, but what about sine 180 degrees or sine 225 degrees when the theta is greater than 90 degrees? So firstly, what does cos 120 degrees equal? Well, if we graph it, so if we have the circle here, so I'm not going to actually draw the circle, but we have the graph here, so we have y and then the cos, the x, which equates to the cos theta, and then we go 120 degrees along. We're going to get this line here, so that is equal to 120 degrees, and we're in the second quadrant. And that's because this here is 90 degrees, and then this line here is 180 degrees. So I know we're in the second quadrant at the moment. So the first thing is, well, cos theta, we're in the second quadrant, so it's going to be a negative number. And you can see that here because this value here is going to be negative x. So it's going to be a negative value. But what does it actually equal? Well, if this is 120 degrees, then I know that this angle here is equal to 60 degrees. And the way I can calculate that is by going 180 minus 120 is equal to 60 degrees. Then, so effectively 120 degrees was this angle here. I know that's 180. So the angle between the x-axis and the line is 60 degrees. And that's the angle we always want to find. The angle between the line and the x-axis. Rather than the y, it's always the x. So if we know that's 60 degrees, we know that the magnitudes equate to when you have 60 degrees in the first quadrant. So what does cos 60 degrees equal? Well, that equals a half. So now that we know that, and we know it's negative, therefore we can say that cos 120 degrees is equal to negative a half. Yeah, so next example. So this one's in radians. So sine 5 pi on 4. So the same thing is, draw it in, I have to work out, well, what quadrant is it? Well, this is pi on 2, this is pi, this is 3 pi on 2, and then this is 0. So it's going to be in the third quadrant, because 5 pi on 4 is greater than pi, but less than 3 pi on 2, which, with regards to 4, is equal to 6 pi on 4. So it's going to be in the third quadrant. So we know it's in the third quadrant, and we know the line comes down here, and this angle here is equal to 5 pi on 4. So what's the angle we want to find out? We want to find out this angle. So how can we get this angle here? Well, theta is going to be equal to 5 pi on 4 minus this angle here. So what does this angle here equal? Well, the semicircle is equal to pi, so that's minus pi. Therefore, theta is equal to 5 pi on 4 minus 4 pi on 4, which is equal to pi on 4. So we know that that angle here is pi on 4. Now, is sine negative or positive? Well, sine is negative in the third quadrant. Well, you can see that in the line here. Sine is going to be negative. Therefore, what does sine 5 pi on 4 equal? Well, sine 5 pi on 4 is equal to negative pi on 4. We can see that down here. So what we've done is we calculate this angle here to the x-axis. We can relate that angle there to this angle here. Then we can work out what magnitude it is by realizing what quadrant it's in. So finally, what does sine 405 degrees equal? So the first thing you may notice is that 405 degrees, this is greater than 360. So if it's greater than 360, what happens then? Well, what happens is if you go from this point, so we go around 360 degrees, then we keep on going, so it goes around. So effectively 405 degrees is just equal to 405 minus 360. So it keeps going round and round and round. And it doesn't matter sort of how many times it goes round, whatever quadrant it's in is the one it ends up in. So 405 degrees is equal to 360 plus 45. So that means that 360 plus 45, we're going to end up in the first quadrant. So this angle here is going to be 45 degrees, as we've gone all the way around for 360 and then we've added 45. So we can say that sine 405 degrees is just equal to sine 45 degrees. Now, if it was radians, you can think about the same thing, but instead of being 360, you have 2 pi. And this is useful for when we graph, because this property of sine and cos, that it keeps on going around, so it just replicates itself, is very useful when it graphs, and it means we're going to get repetition and symmetry when we graph it.